What's the other? And John, do you know which after dinner drink humanoid bots prefer to serve? Port.
Oh, gosh. Hey, y'all, it's Dr. Know-It-All. I am here with Dr. Scott Walter again. First of all, a quick apologies if you hear any noise. Family is in town for spring break, and there's several children here, so I asked them to be quiet, but you know how that goes. Second of all, we both have our Teslabot love shirts on, so there you go. Yeah, black and white, I guess. I don't know. Are you the Sith or am I the Sith? Which one?
No, Stormtrooper Sith. You're Stormtrooper white. I'm Sith black.
Oh, so we're both bad guys. Okay,
those are the two modes that you have, like, the light and the dark mode that everyone keeps talking about. I'm usually the light mode when I'm on my phone, and everyone goes, "Why aren't you dark?"
I think I'm just old because I actually prefer light mode. It's easier for me to read because it looks more like paper.
It's kind of funny, when terminals, we were used to the old-fashioned terminals, and they were always dark, and you had the light lettering on it. I remember when Sun Microsystems came out, when they were the first one to have the white background, we were all like, "Oh, when you do that, you got to wear sunglasses and stuff like that." And only to find out that I'm like, wow, I actually am preferring that version to the old school way.
I know. I just it's kind of weird, but I know everyone's like dark mode now, but I'm not.
The next time someone says I have to use dark mode, I'm going to remind them and say, "Do you realize dark mode is the original old school?"
Exactly. It's
like, and you keep on saying I'm old school. I don't want to be old school anymore.
Right. Okay. So do we want to talk? Let's talk about what we're going to talk about here, which is
it was kind of it's a bit of a slow news week so far regarding humanoid robots, because we're getting off the sugar high from last week of NVIDIA and everything else that was out there. It's been more of an FSD week, but
yeah, that's true.
This Pearl came out about an hour or two ago.
Yeah, so let's look at this. I'll just read it real quick. Sam Koros here. A humanoid robot is less than a tenth the weight of a car. Can the manufacturing ramp be 10x that of a vehicle? Does that even matter? Seems like the constraint is going to be software capability, not manufacturing capability. I will push back on that a little bit, but anyway, the more important part here is Elon said complexity per unit mass, it's much higher with humanoid robots, but I still think it ends up costing less than half of a car. So maybe we start with the end of that. Half of a car, how much does a like a Model 3 or Model Y cost to build right now?
Well, okay, so we have to decide what they mean by a car. Are we going to be talking about the $25,000 car that Tesla wants to build, or the current version? So the current version, and again, is it the base model? Is it the high end? What kind of car are we talking about? But if you're really looking at the lowest end, lowest trim car that Tesla has, what is it, around 30 or 35? Now that's for us to buy it. And I think Elon's talking about the cost to build it. So if it costs them 20, if it costs them 30 to build it, that's 15. If it costs them 25, then it's 12. And if it costs them 20, which it may eventually, we're talking about 10. So, don't take the tax rebates and stuff like that, because it comes down to how much does it cost them. Yes, they got government incentives and everything else, but you really want to kind of look at that way. Whatever, we're talking about under $20,000, no matter what.
Yeah, I mean, so here we've got, this is basically the cheapest car that you can buy from Tesla right now, not including the tax break, and that's $36,000. So if we just kind of just threw 40,000 as a rough estimate out there, that means that we're looking at the Teslabot costing about 20 to build. So
that's in line with what was been said before. Elon had talked about it, being something you could buy for your grandmother. That it shouldn't cost more than a car, less than a car. And we've done our own bill of materials. It's around there. The other humanoid bot manufacturers are, higher. They're like in the order to 40 to 50. And they talk about not cost now, but where they're going to get to. Now, Elon did follow this up in that eventually it should they should be able to scale it down more. Now, what I want to do is I want to back up a little bit there and go to what Sam actually asked, because right now, if I was an attorney, I would turn to the judge and say, "Your Honor, the witness is not answering the question."
Exactly.
Elon did not answer the question. Now, Sam works for ARC.
Right.
And the question he was asking was, 10 times that of a vehicle. Does that mean it's going to be 10 times smaller footprint for it, or the ramp? And he was talking about the ramp. Does that mean it's going to be 10 times quicker, or what is it? And it's really interesting that Elon, it seems to me, he really evaded the question. Almost like he didn't want it to be answered, because it's almost like a closely held secret. Now, if he said, it can't be, and it turns out really easy, and everyone's going to point to him and said, you weren't being forthright with. And Elon does not like to lie. I mean, he really doesn't. He
Yes.
believes in what he says. Now,
Right.
sometimes he's overly optimistic. He's got optimism bias, but he is very measured and careful when he talks about things like that. So it's sort of interesting, but at the same time, he'd once say, "Oh, you kidding? It's yeah, of course it's that." So he kind of refused by answering a question that we like that we love to have the answer. I mean, it's the perfect magician trick. Is that
Right.
we're so happy with the answer. Oh, look, what Elon said is going to be really costly. We forget, like, what was the original question that prompted that to realize that?
Right.
And so I think he's sort of answering the question two ways. One is, yeah, it's going to be really cheap and it's going to be very scalable. Now, the other thing that Sam says there is, does that even matter since the constraint is going to be software capability, not manufacturing? That's what I said from the beginning. I said, this is one of those cases where the prototype will be hard. The production will be easy. That's basically what Sam is saying right there. So getting that prototype out of the way is going to be something else. And then we can break down what Elon means by the unit mass and higher complexity and all that.
Right. So I think the first thing is I'll push back a little bit on Sam. He's a very, very smart guy, but I think, I would push back by saying in the short term, the brains, the software is the problem, but that's going to be solved to a large extent relatively quickly. So let's call it like 2 years, something like that. We're going to have bots that are pretty capable, but then it's going to be like, how can you make 100 million of these a year plus? And so I think like in the short term, sure, but in the long term, I still think manufacturing is going to be a major bottleneck.
It depends upon the bot. So if we look at the designs that are out there, there's nothing that revolutionary about the designs. And assuming that is good enough, you could probably mass produce them. But if it turns out that, no, we have to have very sophisticated actuators because we need to have things that really simulate human muscle. And we want to have more tendon drives and way more complexity to get something more like an android than a robot. Then I agree. It's like, wow, that's going to be very, very complex. But if it turns out the current form of these robot chassis, if it's adequate to do the job, you should be able to produce it very quickly. Now, what is Elon talking about when he says, like, the complexity per unit mass is higher than for the humanoid bots? Now, that makes sense because if you think about it, what's the bulk of the mass of the car? A lot of it is just stamped, sheet metal and, maybe the battery pack and stuff like that. And so, but there's not necessarily a whole lot of complexity there. Now, if you look at my phone,
and the battery pack as well.
There's a heck of a lot of complexity built in this thing. And so per unit mass and per unit volume, there's a lot. And this phone, okay, I mean, depends on what kind of smartphone you want to get and everything else. Maybe it's about $500 to manufacture or something like that. Now, I can take a stack of these things and, easily get 60 of them together, right? And they will fit comfortably in a box in the back seat of my Model Y. Okay. Yet that box costs as much as the Model Y at that point. And so you're really looking at it if from a per unit volume, that it's because the complexity is more. When you look at the human bot, it's made up of all those actuators, and those actuators are almost like this as far as complexity. So we're talking about taking 40 of these and putting them in the bot. And so you could easily say, oh, 40 of them. And if these are like $500 to $1,000, say $1,000, that's 40 grand right there just on that. And then we still have to have the cameras, we still have the batteries, you have to have everything else. And quickly you get to like 45, 50. Which is where most of the other bot manufacturers are, because they probably see they could get the actuator cost down eventually. But right now they say, the path is to like $1 or $2 grand per actuator, something like that.
Right. Yeah. And I mean, what did Agility, they just said it was either 200 or 250 to build each robot right now. So that's current.
Wow. I hadn't seen that much. Is that what they're selling it for? Is that how much to build it? That seems really high for the Agility bot.
It might be that they're selling it for that much, but I have to go back.
It could be that they're selling it because I think it was one of the companies was selling it Unitree. I think they're somewhere between 100 to 2 or no, it was not them. It was Fourier. I think they were somewhere in that order, depending upon what kind of research organization you were. Unitree, I think it is somewhere around 100 grand, but they don't have hands, so that you can produce them for under 100. There's no doubt about it. But right now, we could say that the cost of the Optimus bot, the cost of Figure, those, because they are built by hand, are probably $250,000 or more, depending upon how you do the accounting on that, because of the time and effort that goes into building those things. But when you scale them up, you should be able to get it down. And I guess that we'd have to say also that the question was a little bit poorly worded as far as what 10x ramp means.
Yeah,
and maybe it was almost like intentional, like, oh, ask a vague question, get a vague answer.
See what you get out of the whole thing.
Yeah.
So yeah, I'm actually trying to like hunt around a little bit because um yeah, I'll have to keep poking around for it, but I unfortunately did not mark that down. I think it was on X, but it was not cheap. I was actually very surprised at the cost, and it
That might
might
be
have
what they're
been,
selling it for. Yeah.
yeah, it might have been what
And
they're
are they
selling
selling
it.
it or are they leasing it? It sounds like for that, they're probably selling it.
Yeah, it was definitely over $200,000, and I think now that I'm thinking about it, it had to be selling. But if I find it, like I'll put
Mhm.
I'll overlay it over the video here because I'm not finding it right now, and it's one of those things I don't want to spend forever looking at it. But
Right.
anyway, it's so if you start thinking, and obviously Elon is talking here. If we look at this again, he's saying it ends up costing less than half of a car. So he's not saying that the current cost of Optimus is
And the other thing,
anywhere
he's
close.
not saying we're going to sell it either.
No, 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 no,
He's not.
no,
He's really
no.
he's really talking about the cost basis for being able to build it, and we're
Right.
pretty sure it's going to be leased out for a while.
Yeah.
Now,
Yeah.
I think the other news that we haven't talked about. I don't know if we're done with this. Is remember the news from yesterday? Was it yesterday? Yeah, I think it was
Oh,
yesterday.
gosh, which one?
That was the job
There was a
opening.
legal there's Oh, yeah, 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 about the scaling or I don't know, whatever,
No, no, it
delivering
was
op
looking for technical writers for the documentation for the
Oh, yeah,
user
yeah.
manual.
See, there was a lot of news this week because there was
Yes.
also the job posting about going and sort of becoming the person that, like, was putting Optimi in factories and
Oh,
stuff
that's
too,
it,
so
for the pilot
yeah,
program. Oh, that's old
yeah.
news. That's old news,
Oh,
John.
sorry.
This is the more recent one. Is
Oh
someone
god.
actually writing the
Yeah.
customer manual, the user manual
Right, right, right.
for Optimus. And I got to see a sneak peek of the early draft of that.
Did you? Oh, cool.
Yeah,
Okay.
it's like an 8-page PDF. Cern Basher sent it to me,
Okay.
and it's in there. And I suspect what it
Gotcha.
is, it's the draft that he's going to use as part of his job application because I think he probably
There
wants
we
to
go.
apply for the position. So he's showing them
Cool.
how he would actually document
That's cool.
the Tesla
Okay.
bot. So so I mean, yeah, it's rather interesting that you don't bother to have glossy documentation if you don't actually plan on having it in
No,
customers' hands. Internally,
no.
it's like, I don't care about the document. We get enough of these
Yeah,
little scraps of paper here and there, and just talk to that guy if you need to know something. But if they're going to the effort of doing that, and it's usually something you don't do at the very beginning. It doesn't hurt sometimes to have technical writers at kind of the
right,
beginning of a process to figure out how to start pulling these together and tell you how you should get stuff together, make it easier at the end of the process. But usually
right.
it's something that comes much later. And it's still, I don't know, at least a 3 to 6 month process before the technical writers would have like that first draft that you would be
Right.
able to push out.
Yeah, so and here you go. There's CERN writing about this. But yeah, so
Exactly.
Sawyer
Yep.
Merritt, seeking technical writer. By the way, I have actually done this. I've been a technical writer at times for things, That's where that physics degree and English degree actually come in handy. I can write about difficult
Mhm.
technical things. So very interesting. At a different point in my life, I would absolutely have applied for this. I'm a little bit too far into my career for that, but
Mhm.
anyway.
Well, if I was to do it, I would just have ChatGPT do it for me. To
Oh,
to
I
me,
I was
it's
honestly surprised that
it
that wasn't
seems like
there.
you should have the tool because they're doing tons of internal documentation already. I mean,
Right.
that's just part of all your reports. And
Exactly.
it just seems like you should be able to siphon all this stuff up and then just spit out something good. And then just all the technical writer has to do is kind of read it and make sure it's correct
Right.
and it's readable. That's about it. Okay, yeah,
Termi
17 is the one that
Terminator mode.
that's the Terminator mode. Yeah, yeah. How to disable Terminator mode. Yeah.
So they're coming soon. Optional upgrade. So yeah,
Yes.
that'll be if you'll have to just give it some steroids or something like that.
Yep.
What would be the
Yep.
robot equivalent of steroids? I don't even know. Would it be what would you do? Feed it some iron or something? I don't know.
I don't
But
know.
anyway.
Just a higher voltage battery pack.
Yeah, there we go. You go from LFP to NMC chemistry, and it's like
Yeah. Yeah. Yeah.
jacked all
Yep.
of a sudden. So yeah, so there's things happening. There's things popping on the Optimus front. So we can actually talk a little bit. Actually, I haven't had a chance to ask you about this. What do you think about the full self-driving going out to everybody?
Oh,
Like,
okay.
yeah,
You haven't talked to me, but you've probably seen the post I put out that got, let's say, a lot of traction,
yeah,
where I said it's I used the famous meme of the two astronauts, and one of them sort of saying that wait, FSD is a data ocean,
right,
and the response like it always has been, and I didn't
right.
come to that on my own. I had pretty much the same narrative in my head that I think everyone else did. It's like, oh, it's like the inner quarter push. They want more people. They want to start getting, they want to sell more of it. And it's part of that, just like a marketing kind of thing. It's all about that.
Right.
So I was
Right.
kind of looking at through that lens until, yeah, exactly.
Oops.
Until Meta, in Adrian Spaces last night, he came in
Right.
and he said it was a data issue. And
Yeah.
he really was able to explain it very well. And of course, Meta is just an interesting person to talk about, because he
Yeah.
knows so much about not just AI, but also, how our brains are wired to begin with, and also the idea of sampling bias and all that. And he said, I'm coming in from the bias that I'm from AI, and we always see everything through the data lens.
Right.
And then when he made it, I was like, oh yeah, of
Yeah.
course it's about the data lens. It's all
Yeah.
about the data. It was, and that these are, and everything else is the byproduct, and the byproduct of the take
Right.
breaks and everything else. So my argument has been that he's seeing the breadcrumbs. The first breadcrumb was, of course, they have the compute now. We're no longer compute constrained. Okay.
Right.
The
Right.
fleet has already been out there. And then there was this Operation Vacation cryptic post that
Yes.
also came
Yes.
from Elon about that. And that anyone that knows that the whole idea of that is that once you get everything set up, your engineers can literally go on vacation and come back a few weeks later, and the
Exactly.
system will be better because it will automatically collect all the data that it needs. All you need to do is open up that data pipeline. And
Right.
the other thing that we always agree when it comes to Tesla is they are seeing data that we're not, right? They've
Oh
got the
yeah.
data overview.
Oh
So they're
yeah.
making the
Yeah.
decisions based on the data that they see that we don't see. And we just speculate and we get it wrong and everything else.
Right.
And more
I
than
don't know if I don't know
likely,
if you saw my response here, but I said, I bet, Sam Altman wishes he could turn on another couple trillion language tokens like that. If you think about
yes,
that, because we've almost run out of internet scale language data.
yes, yes, yes.
And then of
Now,
course the data must flow. Of course, I had to put
yes,
that in there.
yeah,
So
no, yeah. So here's one hint:
yeah.
it? It looks like the number of disengagements, or number of miles between disengagements, has been going up to the point right now that they're not getting enough disengagements to keep the data rates
Oh.
going in. It's doing
Jeez.
too well. And Meta's argument is that if they continue on that path, then the improvements will just remain linear. So it's like if they don't increase the size of the fleet, actually
Mm,
the learning will kind of go down, and you
right.
need to have more. So it's really about bringing it in. It's
Right.
very late in the quarter to be pulling this stunt to say it's going to have anything to do with. In fact, it's going to screw up the deliveries, because right
Oh,
now I get a
horribly.
letter from the Tesla Owners Club of Florida to say, oh, Tesla has reached out and they would like us to come and help train people on FSD for getting the deliveries. So,
Right.
in effect, it's going to have an impact in this quarter, but not necessarily a positive one, because even
No.
if people like it, they're not going to subscribe until the 30-day period is over. And
Right.
I'm looking at my calendar right now, and,
Yeah.
and I believe 30 days from now is sometime in April, which
Right.
is the second quarter. Actually,
Yeah.
it's after tax day. So
Yeah.
it's
Oh,
it's like,
oh, why'd you have to
yeah,
remind me of
yeah, I
taxes?
had to bring it up. Yeah,
Oh,
I
that's this
know. It's
that's
like,
this weekend's project. I'm not
yeah, I
happy
know. I
about
got
that.
something from my accountant too that I'm missing, like a bunch of things I gotta go dig up.
Jeez.
Okay. The so that's sort of what's going on. So when you, after listening to Meta, it's like, oh, yeah, it clearly is that, and that everything else is a byproduct, and you can look at it through that lens. It doesn't mean
Right.
that they weren't seeing the benefits of being able to do it, but that was the domino that
Yeah.
basically had to fall over. It is that they had to be at this one particular place where it made sense to do it. Now, the other thing is, again, what Meta talks about is that he's afraid of sampling bias constantly on everything. And right now, the
Oh,
sampling
good point.
bias is early adopters.
Right.
We don't have a good data set of the late
Right.
adopters,
Yes,
of people
exactly.
who don't really know how to do it. So we need to get the people who are more likely to disengage and
Right.
intervene, because they don't quite know what's going on. We need to see how it's going to. We need to get a much larger, broader training set. Now, it doesn't mean that a lot of the pushback where it says, "Wait a minute, that's what they get shadow mode for. You don't need this. You get shadow mode." So, well, shadow mode only
Right.
does so much. It's
Right.
useful, but it doesn't do everything. They've got the simulations; they can simulate all the way. And say, yes, that helps, but you get this strategic triad that you're kind of standing on. And one of them right now, one of those legs is getting short. And that is they're not getting enough data. And it's time for them to increase the amount of data that's coming in, which means you're probably going to get this virtuous cycle now. That's going to come back. The take rate's going to go up. You're going to get more. The other thing is that I was pretty sure that they would have over 1 billion miles driven on FSD before the end of last year. I was pretty sure that would happen. And the latest figure now here in March is like 880 million. So they're still not at 1 billion. And that's because a lot of people just stopped using it. So they're probably noticing that we aren't getting enough people to use it. And with version 12, suddenly everyone's using it more. I'm using it a lot more. Everyone else is. And then if you get 3 or 4x, you'll easily get that 120 million miles in short order to get you over that billion. And that's around there, that then you are getting a lot of usable data. And then you will start to see things improve rapidly.
And I just figured I'd show you the dear Scott, Tesla's reached out to us. So, if people thought you were lying about that, there it is.
And that was from the to Tesla Florida owner. So that was that means all the owners clubs. Tesla is reaching out. When I first saw that post yesterday, and it was like someone that had made a screenshot that had like EM in it or something like that. I'm like, I don't believe that at all. And everyone else was doing it. It's like, okay, somewhere in here, someone actually believes that Elon has said that. And then Business Insider reported on it. And then I said, oh, that's not real. So I wasn't sure whether to believe it or not. But now that Tesla has officially reached out to the owners club and the owner club has reached out to me, it's like, oh, okay, this is the real deal. That's really going on, because the big concern was like, how are they going to do it? And now for a lot of people who are Tesla shareholders and Tesla owners, we miss those good old days of actually being able to help out with the push. So here we go. There's that opportunity. And then the other last piece I had to put in there is that the whole idea is that the March of Nines is about to end. And we're now going into the April of Nines.
No, but bumped. So there we go. Make sure you get that one in there. So yeah, there's a lot going on right now. And I guess to like sort of tie this back up in a bow, this all cycles back to not just Optimus, but all of the humanoid robots that are out there, that it looks like what George Hotz was saying years ago, which is what end-to-end neural networks is the way to go, is turning out to be the way to go. And it was all about having enough data, all about, one of the big things about the NVIDIA announcement, you said that was last week's news, but the Isaac simulator gym that they could put all of these bots into is a massive, massive win for these robots. And of course, Tesla's had that, but very few other companies have had that. Because, when I look back at AI Day 2022, so gosh, that was getting close to 2 years ago now, but they had that. They had the simulator that was really, really good that they were training their full self-driving on, so they could put it into these situations that were out of control that you wouldn't want to normally have, like a moose walking across the road. I remember that was one of the things that they put in there. But very few other companies had that, and now smaller robotics companies can leverage something like NVIDIA to do that. And of course, NVIDIA gets a huge win out of that, which is that the people are going to then use Jetson Thor as their the internals, the brains, which means that they win big time, because they're going to
be selling with all of it. And I suspect that they're going to be able to learn tricks with one bot and move it to another. So it's right now we're seeing that with FSD doesn't necessarily translate from one Tesla vehicle to another, and you would sort of expect that. So there's probably a little bit of nuance that has to be taken care of in there. And it may be the same thing going from one robot embodiment to another, but I think Google and others have already sort of shown this idea that you can do the training with these actions, what you want to do going out to different kind of robot arms, that can be taken care of. So that will help the small ones, because if we see that the sim to real, the simulations are not perfect. So last week there was 2 clips in there, one showing agility in the kitchen, going ahead and removing the GPUs out of the oven. And when you look at the feet, you begin to realize that the feet weren't actually on the ground in the simulation. The knees were on the ground. And then as it stood up, the contact point was lost, and then everything kind of went down. Looking at it, it's like, the physics of that is just like off. It's kind of messed up. Yet as
Right.
bad as it was somehow good enough to be able to sort of do the one-shot training for the agility bot to go over there. So the physics is never perfect. Then you
Right.
saw also that Unitree was able to do backflips, which is amazing. And they
Yeah.
did it also in a
Yeah.
physics engine.
Yeah.
But when you look at it, the physics engine had it perfect. It
Oh,
realized
yeah.
what it had to do with the arms. It came around and it just landed it absolutely perfect. Then the real one does it, and the real one undershoots. And
Yes,
it
it
kind of
did.
falls on his toes, loses its balance, and it recovers, which shows how absolutely amazing their control system architecture is, and the fact that the neural net knows how to stumble and recover. It's been through this
Yes.
whole process of falling all the time that you didn't have to teach it how to recover from a backflip. It already knows. We just want to put it into a backflip and get close enough. Now, eventually, they would probably do that enough times that it will start to be able to stick it, because I think even the bot itself doesn't like the idea that it's stumbling.
Right.
There's a
Right.
reward function to say, oh, okay, you didn't fall flat in your face, but let's not do this in the future. And what that shows is the difficulty in both cases there of the physics model perfectly matching reality. Because you would think, they should be able to do it. They know the actuator torques, right? They know the masses. They know everything else. Why did it underspin? And now,
Right.
if you look at a couple other things, look at the head. You see how the head shakes there when it's all
Yeah, it
done.
was
So when it
all over
does
the
the
place.
flip, the head shakes, and when the head shakes, it's almost like it's saying, "Yeah, I got that." But what that was is that was literally its bell ringing. That was the
Yes.
vibration of it coming around and settling out. Now, if you look at
Yep.
the physics, that doesn't happen in the physics. The
In the
physics is
engine.
not
Yeah,
modeling that.
here.
It's so stiff, it's not showing it. So you can
Right.
see the physics is a good approximation. It's not a perfect approximation.
No.
So it
And also,
gets
I
you
believe the
close,
feet.
and it's coming
Yeah.
around and it just plants it, and boom, it's right on in
Right.
there. Now, most emotions are grossly the same. They're similar. It's
Yeah.
attempting to do the whole thing. So they know this is what you have to do it. But in the end, you still have to do the reality. So this whole idea of sim to real, you need a little bit, which is why you still need a bot fleet out there
Right.
actually demonstrating this stuff and then enhancing it. And I would not be surprised to see in like a week or two, they show it to us and it just nails the landing every time.
Yeah, exactly. I think it's feet. I was watching because see it's actually much lower than it is. If you could do a side by side, you'd notice that his upper body is lower than it is in the
It's
virtual
following
version.
more. Yeah, there was
It's
something about the gravity. Yeah, it's almost like gravity's not the right.
or I mean, it's also
concept.
possible doing a backflip requires an immense amount of energy expended from these actuators in really, really fast order.
Well,
So
well, well, that's what the simulator should be able to do if it's modeled correctly. But
yeah,
that's what it comes down to. If you're not really able to model your motor torque responses
right,
exactly the way it's going to be, you're going to be overly optimistic on what it's going to be able to do, and you
right.
attempt to do it, and of course, it can't do it. So
At,
that's
at this
one of the
point,
tricks
I
of
would have
modeling.
assumed this thing was going to fall flat on its face. I mean, that's impressive that
At
it's
that
able to
point,
recover.
at that point, it's a belly flop. You look at that;
Yeah,
that
it
should be a
looks.
belly flop.
Yeah, it's amazing how quickly it's able to get its legs under it.
Came around. I'm not even sure if its hands touch. Its hands came really close, but it never
Yeah.
did. Somehow it gets it down there. It gets on its toes
Yeah, and then
and
is
then is
able to
able
kind
to
of
pull out of
spring
that
itself
pause.
back up.
Yes. And then, of course,
So it
it's
actually
losing its
does it
balance there, but it uses that
right.
spring up there to allow itself to catch the balance. Because again, that's the idea of a controlled fall. You're going
No,
through a
it's
controlled
the
fall.
toes definitely don't hit the I mean, the toes. The arms don't hit the ground
The
because you
arms
can see
don't.
when it goes
Yes.
full
Yes.
speed, it almost does,
I
but
mean,
not quite.
yes, exactly. I feel like we're at the NFL referees booth right now, trying to figure out
Watching
was
the
he down
replay.
or not? Was
Yeah.
he down or
Did
not?
he contact the
I don't know,
ground?
John. His knees didn't touch.
So yeah, I mean, this is a very impressive accomplishment, but part of the impressiveness of this is just the fact that these actuators are operating. He's also like super light. Um,
Yeah, he's the
but
lightest of them. I think he's no
yeah,
more than 50 kilograms or something like
I
that.
think it
That's what
says
they showed.
50 kilos. Yeah, it says at the
50
end
kilos.
here.
Most of the others are over 50. Yeah.
Yeah, so 50 kilos, 1.8 meters. So this is I know that Boston Dynamics has done this before, and people are like, "What's the big deal?" This is all electric motors. This is not hydraulics,
Not
and
hydraulics.
that is really impressive.
Yes. And, and
So
and kind of the way that
yeah,
was also being taught, the teaching
yes,
technique here of using
yes, and
kind of
not
the
programmed.
using reinforcement learning inside of a simulation to go ahead and figure out how to do this flip.
Yeah. So let's do 0.25 speed. Here we go. Get that sense. But you can see it's a little different in the virtual world. He gets up higher. Look at how high he is compared to what he was. Yeah. So that makes a huge difference. Because if we go back now and watch this guy, look how low his body is. Yeah. Well, not nearly.
And they're both,
so
I mean, he's off a concrete surface, so he should be getting a good spring. It's rather interesting that he's not quite got the same thing. But again, it just comes down to how well the physics is being modeled. Leaning back maybe a bit soon.
Well, I think a lot of it just might come down to the fact that the actuators aren't quite as powerful. Like they can't deliver.
You know, what it could be is that the actuators individually are able to. So you know exactly how an individual actuator is able to respond, and you model it that way. And now the problem is the batteries can't deliver that much to all of them at the same time.
Oh, that could be true. It might be just a little bit, power.
So they need to model that a little bit better to realize that, whoops, each one of them is going to be a little bit less. And so that might be like a feedback loop. So they may be able to take the reality back and say, oh, okay, you think you're doing this, improve the model. Now that the model knows its real limitations, it's going to have to go through and figure out what's a different pose that we have to do to be able to pull this off. So that could be a sim to real and then a real to sim. And if you do that a few times, then you'll probably be able to nail it.
Right. So yeah, so really, really interesting there. I find that pretty darn impressive that a robot with electric motors is able to do that. I don't think anybody's going to be competing with them. And if you expect Optimus to do that, it's intentionally not designed to do that. Its actuators move relatively slowly. And those linear actuators are not going to be able to create that kind of rapid
burst. That's what's going to be interesting is to see. And that they've gone all rotary actuators, but they are using the rotary actuators in some cases to create a linear motion where you need it. So down in the ankles, for sure, there are no actuators actually in the ankle joint. You have these control rods that are going up and down. They're doing it the same way Optimus does. The thing is, those control rods are being actuated by the rotary actuators, which are kind of like up around where the calf muscle is.
Which is these guys.
I'm not sure if they're doing a similar trick with the knee, whether there's an actuator in the knee joint or whether there is a linear drive or rod that's kind of connected to one of the actuators up closer to the hip. That's possible.
Yeah.
It's been hard to see in some of those. Now, but everywhere else. So I think the elbow is actually an actuator built into the elbow. I don't think.
It looks like it is. And of course, it doesn't have hands. So, there's each one has its own benefits.
Yeah. And now what they're doing is, kind of down in the lower leg. It's a little bit similar to what agility has also done in the lower leg. They also have rotary actuators that have these rods, but they've been able to do it in a way that's a bit more compact. I think it was like P&D Robotics that a few weeks ago came out also with another design where they also made a slight twist in the way that's done. They crossed the rods a little bit in the way it goes into the foot. And it looks like they did a very careful analysis of how all the different companies are trying to solve that problem and came up with their own unique twist. So that's why it's interesting to follow these different bot companies, is that they're all are trying to solve the same problem. And they're all trying to see how they can optimize on someone else's approach, because, and when that's happening, that means they understand the problem. If it's a direct copy, it means they don't know what they're doing. But if you see something that's a little bit different, it's like they've gone in, they've done the analysis, they understand something, and they think their approach will solve what is maybe a remaining problem.
And I mean, one big disadvantage of this bot is its chest doesn't move at all. Its whole torso is locked. And even though humans can't move very much, we can still, if you're trying to expand, you can utilize your torso to help.
I don't think it has any head movement either. So.
No. I mean, and the head is very much like Aptronic's Apollo in the sense that it's just kind of hollow. There's not a lot going on.
But I think Aptronic's
not a lot going on up here.
But in this case, I think there's no neck movement.
No, I think it's almost entirely just there for cameras and for the general not creepiness. You don't want it to look creepy by not having a head. So,
and it's kind of weird that it's the fact that it doesn't have a face or anything like that makes it not creepy, but the fact that it's kind of the volume is there, it makes it okay.
Yeah,
And the other
exactly.
thing, it's a very low mass, because the thing they want to be
Mhm.
concerned is like, oh, wait a minute, we don't want to have this real big, heavy thing
Right.
up there unnecessarily, but we need to make sure there's something there.
And it can jump and it can do a whole bunch of other things. So it's a very impressive demo, but engineering, there's a big engineering trade-off here that is that robot doesn't have hands. And in terms of
Yeah.
doing like useful factory work or something, it could do cool jumping jacks and do really cool parkour, but
The only thing it's shown
it's
is
not
that
gonna be
with those
yeah.
hands, it was able to take a box and kind of move it off of their
Yeah,
dog,
yeah,
and
yeah,
move it over to there. Um, so it looks like they have that. I'm not sure how much end to end they've got built in right now. If they're working with
right,
NVIDIA, they're probably starting to get a lot of that. Eventually,
right.
the hands will probably come in. I know that they
Yeah,
want to do
yeah,
that, but my biggest concern is what is the energy consumption for this. So
yeah,
the bot's got
yeah,
a lot of power. And the thing is,
right,
and it can go 7 miles per hour, which is pretty quick. But if you can
right.
only do it for 30 minutes, then that's going to be
Yeah,
a problem. So what we don't know is was the actual duration of this thing is. So
yeah,
it may be the hair. The thing is, it may not be, it needs to be a tortoise.
yeah, yeah. Well, or there may be different use cases.
Yeah.
I haven't really sat and thought about the use cases for something like this, but perhaps an emergency type bot that has to be able to get into a burning building rapidly or something, that
Yeah,
could be
there could be a variety of them. Even
yeah,
on the shop floor, you might come up with something where you need a
right,
bot that's able to quickly
right.
scurry from one location to another, do
Yeah.
something, and
So,
that's it.
the cool thing about this, the part I love about all of this is that we have so many different
Mhm,
possibilities.
mhm.
It's really cool. And
And they're all
I'm
going to
very
learn from each other. It's like, okay,
yeah,
what was it that that allowed them to be able to walk that fast?
right.
Was it just
Exactly.
something in the design of the actuators or something else, or just the fact that they're willing
Right.
to go at 1500 watts or something like that? It could
Yeah.
be.
Do you remember what was the name of that crazy looking like AT-AT walker thing that you said we need to have Ewoks attacking it?
Was it
Uh
Limex or something like that?
oh yeah, probably Limix. Okay, hold on. Let me see if I can go back and find that because that
Yeah.
was cool too. I thought that was really all right.
Yeah.
So
I mean, as soon as I saw it, it's like, oh, that's such an obvious retort to go to. And I'm sure
yeah,
others must have made the same reply. I just never saw them. But I
right.
was surprised how many people were like, "Whoa, whoa, what a unique take!" It's like, they're like right out of Star Wars. Are you
Yeah,
kidding me?
mean, literally, as soon as I saw that, I was like, "That's the command ship from Empire Strikes Back." It's the one that's like,
That's the ATAT right there.
yeah. Oh, hold on. Let me turn up the speed. I've got it set down to
That's not a
0.25.
lightsaber. That's just a stick. Yeah.
I know, but still, we should put somebody should just special effects in a
I mean, I
lightsaber.
can't believe that they didn't think of just using a lightsaber. That really would have gone viral.
It's very impressive though because its hips actually are able to like move in. They're able to spread out like splay. And
Yeah.
so it's pretty impressive stuff that it's able to stand up. So it says reinforcement learning, but it doesn't say whether that was done virtually. I assume that was the case. But obviously this is really cool too, is that it's just so small you can just take it out and like you got a little walker out there.
Yeah. And whether they just let it run around in the woods and that's how it learned to walk.
Yeah.
But
Yeah.
yeah, my,
So
my
I just
retort was that they need to add Ewoks to the training set.
yeah, exactly. Jub jub. Jub jub. So I mean, but this is very impressive also. Again, stuff that we've seen Boston Dynamics do previously, but I think a lot more hard coded. This is more
Yeah,
neural networks.
and the Cassie bot that Agility is built on is also kind of like that. It was
Mhm,
just a walker
mhm.
that went
Right,
around that also was just bipedal. That's the version that still has the bipedal world record
right,
for the
right.
100 meters.
So, but this is impressive stuff because ground that I think it slips right there. Yeah, so it slips and then it gets itself right back up again. But notice how those hips completely come out. It's like an impressive range of motion that it
Yeah,
has.
it's yeah, without hands or anything like that to balance it,
Right.
it just pops right up. You just think about
Yeah.
trying to do something like that. So
And let's not forget that when the robots wake up, they're going to remember who kicked them. So
yeah,
I'm not going to
well,
be that guy. I'm not kicking them.
in many ways, some of them probably realized that it was to their benefit. Like if you
Right.
look at the Unitary bot, it was like all the knocking over and everything else for it to learn how to
Right.
recover from stumbles is why it
Yeah,
was able to do the backflip.
exactly. So
That's the muscle memory it now has on being able to reflexively recover from any sort of stumble. And the
right.
more and more that you do that, the better it's going to be. So you're just going to constantly see it. They're clearly getting a lot of it in the simulation data. We were able to
Right.
see that with the NVIDIA with all the bots walking around and bumping into each other. I think someone talked about agility playing King of the Mountain and going up
Right.
there, knocking everyone
Yeah,
else
that was
down.
really funny.
Yes.
Let me see if I can find Isaac Sim. Let's see if I can find that video because that was really cool too. Although I think, unfortunately, it's going to be, I think they called it Jim. Let's see if I can find that quick. No, I'm finding the sim stuff, but not. Okay, wait a second. Here we go. Maybe I can find it if I dig through really quick. But yeah, the simulation that allowed it to do zero shot learning is zero shot transfer, excuse me, is very here we go. I think this is it. It's just a little piece out of the okay. Yeah, let me pop this over. So just watch here. I think, yeah, there we go. So this is the gym. And so it's basically learning. So that's Aptronic and Digit, which is crushing everyone else. And I think Unitree's over there. I don't have all of them, but yeah, it's unfortunate because it's a very, very brief little section, but super cool. And I think we also saw Aptronic doing this where it was like able to turn on a juicer and stuff. And yeah, but this part is really cool. So yeah, and you can see that they were pretty, problematic. I love how he's just like, you're out of here. And let's see if I can also find, but there's, uneven ground and everything. So you're getting a lot of reinforcement learning through all this. And I'm trying to, yeah, here we go. So this is virtual on the left and real on the right.
And it's sort of when you see that on the left at one point, I guess maybe we jumped ahead too quick. Just when it was pulling it out, you were able to see a little bit of the feet not having proper contact with the ground.
Right. So yeah, but I mean, it's all, this stuff is all happening very rapidly. And so, a little bit the way that like ChatGPT and other large language models were happening last year, it feels like we're getting that sort of explosion that's going on with embodied humanoid robots this year. So
yes, I absolutely agree. It's going to be pretty wild next couple of months what we see coming down.
Yeah.
It's been a little bit more than a week since we've seen one of these big video releases, so you never know.
And the big question is, we've been seeing a lot with full self-driving, but we have not seen any Optimus videos. I thought for a while, last weekend. I thought for sure last weekend they would do a video, but it didn't pop up. So
yeah, maybe not. And but there seems to be at least a couple of posts. Like we started out, we got an idea of what the cost structure is going to be like. Most of the complexity, I think, for the manufacturing line, when we kind of get back to it, is just how do you come up with a line to build actuators? And they're not going to be really big motors. It's going to be small motors, but going to be windings going to be needed and so other things. So imagining it's going to be mainly some equipment where there may be some human operators that are typically like loading some things into some equipment that will make the windings, and maybe you take it out and put it in something else. So something that is very, very repetitive, which means like, oh, that the bots can do something like that. A lot of the line might be kind of like the battery line that we see, which just does everything kind of on its own. There's like almost no human intervention, except maybe at a few spots. So I imagine it'll be something like that. And then the actuators, when they start coming off the line, then you got to start saying, now you start putting them into the sub assemblies and then into the final assembly. And that's where the bots are going to come in. And that's where it's very easy. It's very light manufacturing at that point, because it's just assembling a bunch of things with some simple tools. The thing is designed to be put together. It's designed to be repaired, limbs to be removed, very easily serviced. So once you get those actuators being built, I don't see that it's going to be very hard. You don't need a huge area.
The central housing, like the central CPU / battery, that's probably going to take a little bit of work, but still.
Yeah, but okay, but the batteries, that's being done somewhere else. So we're not worried about the batteries. We know there's an ample supply of that. We know there's an ample supply of the semiconductors that are needed. So that's not part of the footprint we're talking about. We're just talking about you bringing those things in. Once you have them in, you can assemble them very easy. The body cavity, it won't be very hard. It's just going to be just getting those batteries and dropping them in. I wouldn't be surprised if as part of the Tesla battery line somewhere, they're already just kind of like pulling them off and then making the modules right from there. So you don't have to worry about the packaging and everything else. And it also could be that Optimus is going to be assembled where very close to where the batteries are made, just to kind of get rid of make the logistics a little bit easier there. Because maybe they have the space there. And you don't need a whole lot of space. You do not need a giga Optimus line or anything like that.
Well, and again, just a lot of
a mega. It's not going to be a giga.
A lot of the car is just empty space. So a car is very large as it moves through a line. It takes a lot of space up.
And
But
the whole
these guys,
production process is
yeah,
inefficient.
yeah, exactly. So it's all very huge, but you can easily fit 10 humanoid bots standing up in the space of one car.
Yeah.
Probably a few more than
You've got a lot of movement of the car, and every
Right.
time it goes from one station to another, very little actually gets done on it.
Yeah.
So
Yeah.
you do a little bit there and boom, you go somewhere else. And so if you
Right.
actually look at the value added any line, it just doesn't look like very much. And then
Yeah.
let's not get into the paint line and how much that takes up as far as time and everything else.
Right.
So with Optimus, I could see everything will be much closer on the density, in that like in one area, you can get a lot done at one time.
Right.
It's not going to be, oh, we just do one operation, we move on to somewhere else. I don't think there's going to be an Optimus assembly line. I think what there's going to be is there's going to be all these places where assemblies are done together,
Right.
and the bots just move around and take care of it. So there's not going to be a meat hook where it's just sliding on down. Everyone's like attaching things on it like you would see or an automotive line. It's going to be different. The way they have that thing designed is going to be very different than we expect. So I have some ideas what it's going to look like, but they're probably going to surprise me with some even wilder ideas.
Yeah.
All I'm going to say is, like, I think they're getting rid of the conveyor. There's not going to be a normal.
Okay. So if the new car is going to be built in the unboxed method, would this be called the unbodied method?
Yeah, it could be.
The unbodied method.
Something like that. Yeah. And so what will happen is that, you may have the body kind of starting on some sort of frame or structure.
Right.
It's maybe on wheels that can be pushed where it needs to be, but it's not like it's going to be on a central line where things go around. And so the thing gets maybe moved over to an area where some operations have to be done. But the question is, does it move or does things come to it? So it's going to be a combination of the two, of things just being brought in as opposed to having to go over. It's not going to be move over to the arm station, move over to the leg station. It might be something gets started and it gets kind of pushed out of the way. And wherever it ends up, people just start bringing arms and legs in, or the bots bring the arms and legs in, start attaching the stuff. It does all the quality checks. And then when the thing's done, rather than actually going out to shipping, it goes actually back in to the hive and starts building the next bot, because that's part of the quality control process. And at some point, one of the bots that has gone through it enough times, he's like, oh, I'm done. I'm out of here. And he goes to shipping to go off wherever it is.
Let's go one step further, because why not build so you got the torso with the CPU and all that stuff in it and the battery. You plug the legs into it and then let it walk to the stations. So it walks over to
potentially.
the station where it puts
exactly.
the arms on.
There won't be conveyors. There won't be mobile robots. So the whole idea of the mobile robots is that you're looking at the way Henry Ford set up the line.
Right.
The way he set it up is that everyone was going to be working on one station, and they just do that. Okay. So division of labor is how it was. The reason he did it is because once people get in the zone, they can do that. But if you keep on asking them to change tasks, there's that context which they're really, really slow. So when someone is done with this, rather than that person picking it up and taking over somewhere, he's got to put it on something, on a cart or a conveyor that takes it to the next station. But right now, what can happen is, like, the bot can either be multi-purpose and do a lot more tasks there, or if it needs to go to another station because there's some special tooling there, the bot literally just picks it up, takes it on over there, and completes the task and goes on. And then when done with that assembly, brings it on over to the other bot that needs to be done. So normally what you'd be doing is you're either taking your completed product and you're pushing it onto a conveyor, or hitting the button, letting the conveyor move ahead, because the conveyor sometimes is your work table. Or the other thing is that it's done, needs to get ferried somewhere else and goes on the back of a mobile robot. And that mobile robot then drives around somewhere. And I'm saying you're not going to do that, because what will happen if you design everything really neatly, all the operations that need to be done are going to be very close by. You only need a mobile robot because you have this long haul you've got to do. You're carrying a lot, something really heavy, a long distance. But if you don't need to do the long haul, if you're kind of done here and then the next process is right over there, 3 steps away, take the 3 steps. Don't waste your time waiting for a mobile robot to come in and drop it down. Don't wait for the other Optimus robot to come in to hand that off. Get rid of the handoffs. Get rid of all that stuff. So what will happen is the bots will not be dedicated to any one station. They will just keep on moving around, and they're going to know where they're needed at any particular moment. And if for some reason there's a shortage of arms, then they're all going to go over to wherever that shortage is, and they're going to, suddenly start building enough arms to match exactly what needs to be.
Right.
And you're right. Once that lower section is done, then it just goes to wherever it needs to next.
Right. Right. I could also see, thinking 3-dimensionally, that you could build arms and legs and maybe torsos above, drop them down, and they just go whoop, and then there's just they're all I mean, so you could think of like a star. There's like the torso and the head, and then the arms and the legs and things like that around it. And so you go pick one up, plug it in, pick one up, plug it in, pick one up, plug it in, and the thing's ready to go.
And the thing is, no one really teaches that kind of design for factories. We're just so used to them being flat, and every now and then you need a vertical element because it makes sense, but for the most part, everyone's looking that way. So when I try to wrap my head around, it's like, I just haven't really seen enough examples of how you would do that kind of weird vertical integration. But it doesn't mean that they're not thinking about that as well. And so like, okay, how do we kind of move that in to be able to do it? That's why I say it's going to be pretty wild when it's done. What they have is going to be a pretty small footprint. And I almost wonder if that's why, Elon just like changed the subject, this guy's I don't want to talk about that. I don't want to talk about that. Okay. Because,
these are not the bots you're looking for.
Yes, exactly. So a little Jedi mind trick there. It like changes, like, I'll throw him a bone. Oh, it's gonna be really cheap. It's gonna be half the price of a car. But I'm not gonna say which car.
Yeah, exactly.
So if it ends up being 60,000, it's like, oh, the Foundation Series Cybertruck. That's the one I was referring to.
Right. Exactly. Yeah, there you go. So costing less than half of a car. It doesn't even say Tesla. So
I mean, what is it? A Lexus, Lucid? What is it?
Half of a Lamborghini. There we go.
Exactly. The Rimac, right?
Half of a Rimac. That gives us about $1.5 million to play with or so, something like that.
And the question is it the sales price or is it the actual cost? Because with the Lucid, you have to go with the actual cost of manufacture.
Oh, that's right. And that's higher. That's actually
much higher
than the sales price.
As Jeff Lutz likes to say, it's like they're putting $80,000 in the glove compartment for every car you buy.
Right.
I love that analogy. Yeah,
I wish they would give it to me. I would buy the car.
Exactly.
$80,000 with it. Thank you. Appreciate that. So, all right. Very, very cool. I think we have talked this stuff out. I'm excited about what's happening. And I'm waiting with bated breath for Optimus to make another showing so that we can break it down. But we will see.
So we can have something to talk about,
Yeah, I know. There's just so little there's nothing to talk about these days. And still we spend 50 minutes talking about it. So there you go.
One tweet,
Yeah, exactly.
One little post that long. And here we are 52 minutes later.
It's the Scott and John show. All right. Well, thank you everybody for watching, and definitely follow Scott. You could see the whole time Going Ballistic 5 there. Follow him on X. He has lots of, what would you say, bon mot that you express on is it bon post?
Yeah, I don't know. It's just like sometimes I can be careful about like the thoughts that I put out there.
Right. We'll just have to keep you pumped up on dark chocolate, and you'll put out really good posts all the time. So there we go. And if you don't know that, you got to look back in his posts. And
okay. Well, yeah. So then we do come down to the bot jokes, right?
There you go. Okay. So yeah, send us out with a good bot joke. What do you got?
Okay. Well, I guess I'll do two. The first thing is you may have noticed, based on the kitchen scenes from last week with NVIDIA, Digit Agility bot and the Aptronics Apollo bot are probably dating. Okay. And do you know why they decided to start dating?
Whoops. Hold on. You're going to have to start that one over again because actually, you're still frozen. Weird.
Okay. Still frozen. Are we back in here now?
Yeah. I can hear your voice at least now. Yeah, your voice completely cut out.
Okay, I'll bring you out with two. Okay. Now these are not CERN bashers because CERN's have been pretty lame. He may be married to a comedian, but boy, she's keeping the material to herself.
Ouch! So, all right.
So John, last week we saw two videos of Agility Digitbot and the Aptronics Apollo bot, sharing the same kitchen. So that's got me thinking that I think they're dating at this point, and I think I know why.
Okay.
It's because they find one another well articulated.
All right. What's the other one?
What's the other? And John, do you know which after dinner drink humanoid bots prefer to serve? Port.
Oh God. So bad.
And the third one is too risque for the cold open and also the outro. So if you want to find out,
just follow Scott, follow over there, somewhere. Follow Scott someplace over there, and you can find out what the risque version of the joke is. So, all right, everybody, thank you all. We had to record that like 3 or 4 times because the stupid internet connection was trying to censor us. So anyway, everybody have a good day. We will see you in the next video, and ciao. Bye-bye.
Bye-bye.